Hi, I'm Arlen Meyers. I'm with the Society of Physician Entrepreneurs and with MI10. And welcome to this monthly session. We're pleased to have our guest, Shree, who's going to talk about neurotechnology and AI. Before we do that, Anthony, do you want to introduce yourself?
Sure. Hi, everyone. As some of you know, I'm a pediatric cardiologist with an AI background.
Okay, and just a couple of ground rules. This really is intended to sort of be a learning opportunity for everybody. Shree is going to present maybe for about 15 minutes just to sort of tee up the subject. And then we're going to open up to questions via the chat, or if you have a question, raise your hand, or just go ahead and unmute yourself and ask the question. If you have not been with us before, this is an opportunity for you to share your LinkedIn profile in the chat. So if someone wants to get in touch with you, or collaborate or compare notes, that's a good way to do it. And it also helps to build your network. Um, Shree, just before you get started, just tell us a little bit about yourself.
Sure. Thank you, Arlen and Anthony and Rebecca, for this opportunity. I am Srikanth Mahankali. I'm based out of Cleveland, Ohio. I am a radiologist by training, a former faculty alumnus of the MD Anderson Cancer Center in Houston. Currently, I'm in the advising and consulting space. And two things that are relevant to this audience and particularly to this presentation are I'm on the implantable brain-computer interfaces collaborative committee as a working group member, and that's the only clinical neuroscience committee in which the FDA participates. So I got involved with them sometime early this year. And then I'm also with the National Science Foundation. They put together a working group helping the federal government upskill the workforce in terms of AI. So those are two things that I just wanted to throw out there. And that's why the whole idea of putting this presentation together was to try to interface both of those and then hopefully contribute a bit and then learn from all of you experts.
Great. Take it away.
Sure. So thank you again. This morning, actually, I'm going to be talking briefly and giving a quick overview in terms of neurotechnology for those who are not exposed to this domain. I have 57 slides, but I'm going to kind of breeze through and get to the last few ones, which are more important for this audience. So in terms of neurotechnology, the first thing that we need to know is what do you mean when you say neurotechnology? And basically, these are three things that you need to know. One is neural interfaces. Two is brain mapping and neuromodulation. Neural interfaces are basically devices that connect the nervous system with external technology. Brain mapping, which I'm presuming quite a few of you are familiar with, is techniques that allow you to visualize and understand and also map neural activity. And then when you want to use targeted stimulation methods to alter the brain function in some way, either in terms of understanding disease or in terms of getting greater insights into the brain, then that comes under the domain of neuromodulation. So for the neurotechnology ecosystem, there's basically four fundamental spokes to this wheel. There's hardware, there's software, there's a research component to it, and then obviously there's a clinical component to it. In terms of hardware, we basically are talking about implantable devices, wearables, and sensors. Software, signal processing of all of the neural data that's coming, AI algorithms, and then how you manage all of that voluminous data that's coming to you. From a research standpoint, it's obviously neuroscience, but there's a lot of material science and bioengineering as well involved. And then from the clinical standpoint, we have to try and understand how all of this ecosystem works in terms of treatment protocols, rehabilitation, and diagnostics. The current state of neurotechnology is such that it currently has a lot of academic dominance, but there's growing commercial interest over the last couple of years with a research focus. There's limited clinical applications at this point, but FDA-approved treatments are expanding rapidly. And then as of 2024, the market valuation was about 10.7 billion, with a projection in CAGR of anywhere between 13 to 16%. Where does AI come into all of this? Basically, as of now, from what's available out there in the literature, there's 3 potential roles for AI from a neurotechnology standpoint. Can help you with predictive analysis, can help you with signal processing and data integration. And we'll talk about this more when we actually get into the discussion. There are 3 areas where this technology converges in terms of machine learning, neural networks, and natural language processing. And the AI neural feedback loop is basically neural signals are captured by all of those external interfaces. AI helps you in decoding all of that neural information. And these patterns are then translated into meaningful data. And then there's a feedback system where the system responds with appropriate action once the interpretation is done. Clinical applications, paralysis and movement disorders, a variety of neurological conditions. There's a role in mental health, and then restoration as well.
Okay.
If you're not speaking, excuse me for 1 second. Sana, could you do us a favor? And oh, good. If you're not speaking, please mute your microphone. Thank you. Go ahead.
Yeah. So I'm going to quickly scroll through these. So in terms of emerging applications, apart from the clinical applications that I talked about, the future envisaging a brain-controlled smart home, potentially going to be useful for cognitive enhancement. There's a role for sleep optimization and also wearables that could emotionally regulate you. So the current market landscape is basically 5 areas. Neuromodulation is the first one. About 42% of the market is in terms of neuromodulation. Neuroprosthetics is about 23%. Neural monitoring devices, 18%. Brain-computer interfaces, of which all of us are familiar with, about 12%. And then the rest of it is about 5%. Who are the key industry players in this space? There's medical device companies. There's brain-computer interface startups. And then there's an increasing role for tech giants as well. Growth projections at the start of 2024, the market size was about 10.7 billion, and it's expected by 2030 that it'll be about 22.9 billion. Okay, so in terms of healthcare leaders, basically you have to assess organizational readiness. You have to plan a strategic integration. You have to potentially run some pilot programs before you scale. And then there's obviously some implementation best practices that we'll talk about when we chat. And then optimization strategies after the implementation is done to ensure that there's outcome tracking, data analysis is ongoing, any protocol refinements that have to take place, and then incorporating clinician and patient input to get the best possible results. So for healthcare leaders and healthcare organizations, there are 3 return on investment considerations. There's direct financial returns, which could be because of reduced length of stay, increased procedure volume, indirect benefits, improvement in quality metrics, enhanced reputation, increased referrals, and then there's obviously a long-term value to all of this as well. The reimbursement landscape is still on the anvil and developing. Current coverage is limited to only established procedures with proven outcomes. There's an attempt to have emerging pathways and new CPT codes for neurotechnology interventions. Detailed outcomes tracking is necessary for coverage approval, and then alternate payment models are being envisaged at some point in the future. So ethical considerations, there's 4 things that you need to keep in mind. There's a privacy component. Who owns the neural data and how is it protected? You have to ensure that there's access across all of the demographic groups. Informed decision-making capacity based on what neural state the patient is in, And there's obviously a personhood and cognitive autonomy aspect to it because neural data is very personal and reflective of identity as well. So, okay. So infrastructure requirements, again, of relevance to healthcare leaders and healthcare organizations. You need network capacity because there's a lot of data coming in, computing resources, storage solutions, and obviously, given the sensitive nature of the data and the privacy component, security architecture has to be, you probably need specialized protection as well. So, okay, so what are the common barriers to implementation? There's obviously a cost concern, technical complexity. Not everybody is ready to handle all of this. There's some worries about workflow disruption and how this will integrate into regular clinical workflows. There's some uncertainty about reimbursement. There's a lack of expertise in terms of team members and team dynamics, and regulatory hurdles still things that need to be overcome because all of the regulatory process right now is like it is for medical devices, but neurotechnology applications may require new CPT codes. So, okay, so how are you going to measure success once you do all of this? It's obviously going to be in terms of clinical outcomes, operational metrics, and financial indicators, which are critical, of course, to healthcare organizations and healthcare leaders. Okay, so future considerations between 2025 to 2030, it's projected that there's going to be non-invasive neural connections that is going to be much more than the implantable ones. There's going to be miniaturization of these devices. So it's possible to do these things at micro scale. Edge computing is potentially going to help with processing all of the neural data locally. And then with advanced AI algorithms, AI integration is only going to increase in the upcoming future. So in terms of innovation, these are the four major ones that are on the anvil. There's going to be enhanced implantable BCI resolution because one of the problems with BCIs is the weak neural signals. There's going to be advanced non-invasive neural interfaces, especially with the anvil of graphene being used in all of this. AI optimized neuromodulation systems are on the anvil. And there's potential for between 2028 and 2030 for bidirectional sensory restoration technologies. So, okay. So in terms of the healthcare leader action steps, there's four things that you need to keep in mind. You have to assess organizational readiness. You have to build a cross-functional team. You have to develop a phase strategy and create a realistic timeline with defined milestones. And then obviously, given the nature of all of this, you have to establish key partnerships, whether it's with technology providers or research institutions. So the four key takeaways that I wanted the audience to know at the end of this 15 minutes is that neurotechnology is potentially going to revolutionize the patient care, given the transformative potential. AI algorithms are going to drive clinical outcomes in the future as AI algorithm advances take place. You need a strategic approach that involves phased implementation so that you maximize your chances of success. And then there's a competitive advantage for forward-thinking organizations and for early adopters. So I think I'll leave it there for that, my first 15 minutes. I don't know if I took 15 minutes or no. So Rebecca, we can go back to stop sharing the screen and get back to the Zoom call.
Oh, thanks for condensing that. That was a great summary and highlighting a lot of points. Before we start asking questions, are there any questions from the audience about what Shree has presented? If so, either just raise your hand or unmute and ask your question.
I have a quick question.
Sure. Who are you?
So my name is Sana Gaspard. I have my doctorate in biomedical engineering,
Uh-huh.
working in the AI space around skin health management. My primary question right now is what is the timeline for this to be a practical clinical application? Since it has so many moving pieces from biomaterials to AI, but then also requiring really good infrastructure like supercomputing infrastructure, and miniaturized neural interfaces. What's the practical timeline for this?
Basically, some of these things, especially from the neuromodulation standpoint, are already in clinical care at some institutions. But the expected timeline for all of this to come in place, from whatever I'm reading and listening, is about 2 years. Potentially about 2 years.
What did you want to make the appointments for?
Especially for the neuromodulation part.
Sree, given Musk's initiatives, so what's happening with that? What is the present state of that?
Sorry, repeat that, Arlen. I didn't catch that.
Neuralink. What's the present status of Musk's company?
They've done their first clinical trials, and one of the challenges with implantable computer interfaces is there's a risk, obviously, because it's a surgical implantation, so there's risks due to surgery, number one. Number two is there's risk for scarring. Number three, there's a risk for infection. And number four, there's some level of technical obsolescence for these technologies. So they probably have a life at this point anywhere between 5 to 10 years. And then there's also a worry about the quality of the neural signals that are coming. And it's anticipated, hopefully, that AI will help not only in decoding those signals, but also potentially even amplify those complex signals. So the first trials have been done. I'm not really on top of where the current data is in terms of the signals, to be absolutely honest, but it's not such a straight and linear path as it is being made out. That's my impression.
Yeah. Susan, you want to ask a question?
Yes, I'm a pediatrician. My name is Susan Gundes, and my question is, have you been using Neuralink or your company in pediatrics at all, any clinical applications that you can talk about, or how you envision it in the future? Like for CP or any other autism, developmental delay, how can you see that occurring?
Yeah, so there are a couple of areas where it could be of relevance to those below 18. One is depression, because some of these neuromodulation techniques could potentially alter mood circuits in the brain. And the other area that's of relevance is addiction recovery, especially for those below 18, because neuromodulation could potentially alter the addiction circuits as well. So those are two areas that immediately come to mind in terms of applicability for pediatric population. I am not on top of whether Neuralink is being used for pediatric population. To the best of my knowledge, no.
Paul, why don't you introduce yourself and give us what you can of the investor perspective. You live in Silicon Valley and sort of in the midst of all this. So what are you hearing about the investor appetite for this? So first introduce yourself and then answer the question, if you would, please.
And then I actually was going to ask a question too.
All right.
Yeah, Paul, I'm in Sick Venture Studio in Palo Alto, California. It's interesting. We actually might be looking into something like this because in our space, there's a lot of appetite for biomarker discovery and assay and test, et cetera. And so, and then not just single prick one, you want time series data, not, every time you take a reading, right? So, so you can track tumor shrinkage, efficacy, immune response, and other biomarkers, and even gene expression. So My question was going to be around when do you switch from like neuromodulation to testing? Like an implant could be very useful for testing, like especially if you implant it close to a tumor, or even for conditions like Parkinson's, Alzheimer's, etc. So that I think is where the appetite is going to be for investors.
Yeah. So that's already one of the clinical applications. So from a pure neurology standpoint, there are 4 conditions in which some of these technologies are already being used. One is deep brain stimulation in Parkinsonism. The second one is vagus nerve stimulation for epilepsy. There's a role for stroke and neurorehabilitation. And then the fourth one, what was the fourth one? There's a fourth one too. There are the 3, in dementia too, actually, neuromodulation, wearable that can help with cognitive enhancement. So Parkinsonism, epilepsy, dementia, stroke. So those are the 4 neurological conditions. And then in those that have paralysis with sensory loss, for example, there's a role for haptic feedback, which allows people with vision loss, with hearing loss, to perceive touch and to be able to hear, because there's a retinal component as well that is there in neuromodulation. There's apparently some devices that can do that.
Sorry, question. So to double click on Parkinson's, because this is a hot indication for investors, what are you seeing out there? I don't know, sorry, it's not my field. So, but what are you seeing out there for Parkinson's?
For Parkinson's, basically deep brain stimulation. And deep brain stimulation has been shown to improve movement and reduce the tremor. That's pretty much what's going on right now in terms of Parkinsonism. And one point I wanted to add in terms of VCs that I came across is there's been a 178% jump in terms of venture capital investment in this space in 2024 as compared to 2023. So currently the 2024 figures,
because of Neuralink, right,
are about 4.1 billion as compared to, so that's a 178% jump as compared to 2023.
One of the incidental things that happened with Neuralink is their last round, somebody had a pro rata and squeezed out all the investors that they'd been pitching for 6 months to come into the round, and somebody had a pro rata and squeezed them all out. And so then they just went and deployed their money elsewhere and created a lot of FOMO in this space.
Good, thanks, Paul. So Harvey, you bring up a good question. And this has to do with the educational aspects of this, of which there are several. But Harvey, you want to ask your question?
Yeah. Shree, good job, man. Good presentation, by the way. So my question here is, what do you see in the future? I just put on the chat, by the year 2030, do you foresee a hybrid roles of maybe a neurodata curator or BCI rehab architecture setup? And if so, do you see that could be a pathway for academic centers moving forward to kind of look at the space? I've been following Max Haddock, who helped co-found Neuralink, and fascinating with the stuff what he's doing, like growing neurons into people's brains and creating that interface. Really fascinating.
It's a great question, Harvey, because just last week, I had a conversation with someone who's in the regenerative medicine space. And there is a role for AI and neurotechnology in the regenerative medicine space as well, which addresses one of the points that you're trying to make. Basically, post-stroke, especially or post-paralysis of any ilk secondary to a brain tumor, for example, there's a role for brain-computer interfaces and neuroprosthetics to work in conjunction to improve outcomes. In fact, there's a case study done in tetraplegia, which is one of the more heavy forms of paralysis, that showed that there was a 85% improvement after the use of neuroprosthetics in conjunction with brain-computer interfaces. And the average learning time, contrary to our impression, to learn to use those devices is apparently only about 5.2 hours, which is not a lot of time. So if you have a support team, a caregiver, and a physical therapy expert, and a neurologist all working in conjunction with other technical experts, it's been shown that the conjunction of brain-computer interfaces with neuro prosthetics and a neuro rehabilitation team, there's almost an 85% chance of being able to carry on the functions of daily life.
So there's a lot of things that we can learn from other medical specialties that have been in the neuromodulation business for quite some time. As you're well aware, there's a neuromodulation society, which is a subsection of neurology, neurosurgery, etc. The other example are cochlear implants. And a third example are spinal cord implants for pain, particularly peripheral or back pain. So my question is, and you may not be familiar with what's going on with cochlear implants, but what lessons can we learn from things that have already been done? And this kind of overlaps with Harvey's question. And Anthony, maybe you can chime in on this. This has to do with the jobs, the sick care jobs of the future have yet to be created. I mean, that may be an oxymoron or redundancy, but because this is going to spawn a whole new generation of people that need to do this stuff. For example, community health workers that are non-college educated do not require a bachelor's degree. And this overlaps with the whole scenario of higher ed, and people questioning it. And do I really have to go to college to make a decent living? And et cetera, et cetera, et cetera. Do you have any thoughts about that, Shree, or anybody else for that matter? And this gets to Susan's question with cochlear implants for kids, which may eventually be replaced by some other technology that does the same thing.
Especially for cerebral palsy. I mean, we have a lot of patients that, where's your work? I don't know if you're even interested in it, but I think that's a big issue in pediatrics.
And why do you say people have to go to college?
Because high school and middle school, elementary school is inadequate at the present state. Did you know that the reading level of fourth graders at this point is way below the national average? It's getting worse every year. Children are not being taught adequately, but I'm not going to get into it further. If you graduate high school, you don't have enough knowledge to adequately go out into the world and understand everything that's coming at you.
I think that's
I'm a pediatrician, so I know what I'm talking about. I've seen kids over 30 years. I'm not saying you have to go to college, but you've got to make public education or even private better. That's all.
Right. And we could get it. Yeah, this is
college is not enough.
I agree, but I am telling you, I'm an expert at this. It's very poor education out there. Kids are coming out, they're not able to sustain a decent salary. And so, and especially in other areas of New York and California, you can't even, they're better than most.
Okay, I don't want to get down that rabbit hole. So let's get back to, thanks for your comment.
Well, I'm telling you, you want to put me on one day, I'll tell you a lot of information, a lot of people
but we'll be happy to put you on.
All right.
The future of the healthcare workforce.
Educate you guys. I'm doing this 35 years.
I understand.
I'm going to educate you what I see every day.
Right. But let's move on. So Susan, we're going to have you at the next thing. Anthony, you want to make some comments?
Yeah, wow, that's a really big topic. I do think that I agree with Susan for sure that I have 2 kids in schools right now. I'm amazed how little homework they get, how little learning they're doing. I think rather than debating whether or not you gain something from college, I think we should be looking at the entire continuum of education and figure out how a resource like AI can help you learn in a precise way, which is what we're not doing now. And there's going to be a lot of self-engendered strategies for learning in the future from probably high school up. And it's going to be a pretty vicious game of how you're going to get the skills you need to maintain a job. For sure, if you don't know how to manage AI in your education, you're going to be disadvantaged. I think I see it more and more in the last couple of years.
So, Shree, are you concerned about the caliber of the present and future workforce to disseminate and implement brain-computer interface technologies?
Yeah, absolutely. And actually, I happened to see Harvey's question in the chat. When he asked it, I didn't get the whole question. Yeah, so yes, obviously, there's a significant need for upskilling of the workforce to deal with all that's coming down the pipeline. And most of the academic centers too don't have the level of understanding needed to do some of this work going forward. So one of the slides that I had was basically there's a need to upskill the workforce for doing things of this nature and this ilk. And to address the question that Harvey had, yes, there's going to be hybrid roles in the future. You'll need a combination of those who have a clinical background, also have a technical background, and potentially be able to interface with people with supporting roles, for example, an AI, a data scientist, and things of that ilk. So you need to be more than one thing to be able to do it. It's unlikely that someone with just straightforward training in only one domain will be able to handle everything that's coming down the pipeline. So that there's a concern for that.
Hansa, what's your 2 cents?
So I just wanted to ask 2 questions. Srikanth, thank you so much for this presentation. It's so hopeful and amazing and just so many applications. It's very exciting. So thank you so much. But I just wanted to ask you I have a question for Srikanth and one for Paul, actually. So Srikanth, like what you just said, like, has anyone done a deep dive into the architecture of the support systems for implementation of these technologies? Because, like, I guess the pessimist in me always worries when we look at devices like 1,000 AI-enhanced devices approved by the FDA last I looked, and how many of them actually got integrated, right? Because then, like, it's the hope is like a balloon that's being punctured, right? So that's my question to you. And then I would ask Paul, from an investor standpoint, do the investors pay attention to the pragmatics of the implementations of these technologies?
So let's start with Shree. You want to?
Yeah. To the best of my knowledge, no. And I actually had a slide that I couldn't bring up where we talked about the potential workforce that we'll need. But in my search of the literature and in terms of preparing for this presentation, basically, I couldn't find anything that suggested that, to address your question, Hansa, that there was something like that in place. So that's something that's needed for the future.
Well, I would argue that that's a much bigger question, that the barriers to dissemination and implementation in sick care is a pretty big issue that most investors don't have their radar. It's not on their radar. I mean, and that's what happens. It doesn't work because it gets out in, we all know that, everything from electronic medical records onward.
But I think the reason, the other part of that, the other flip side of that also, Arlen, and correct me if I'm wrong, is the fact that there's always concerns about how AI is going to take jobs. And that is one of the things that, and I'm sure you guys already talk about it, but that's one of the things where, there's hope for the job force too, right? I mean,
right. And we'll have that
in this regard. Yeah.
Well, can I address that? I don't think anyone should be afraid of AI taking their jobs.
Yeah.
I think that is the biggest unfortunate trauma the world is suffering the last couple of years, because the more you use AI, the more jobs it creates, and the more stuff you're able to do, the more productive you are. So in no no scenario are people going to be left without jobs. You're just going to be super jobified. Maybe 10 years out, that's something different, but I don't think people are worried about that. But Hansawal, can you repeat what your question was? It was something about what investors are concerned about, the workflow or the clinical setting.
Yeah. Just do they look at the factor of, likelihood of integration of the technology or workflow integration as a factor to, them, in terms of like the investment potential of a company?
100%, because that impacts go-to-market, adoption, growth. It's the biggest thing that impacts sales. Workflow, friction. You want a frictionless workflow, and that's what investors are looking for. They're just trying
Shree, so thanks for the question.
So I just wanted to add to that conversation. One is in reviewing all of this space, all I can say is that one, as AI gets more involved with the neurotechnology side of things, I can see new and interesting jobs coming up that have already not been defined before. So there, in my view, and mine's a small, humble view, and that is that AI is not going to take your jobs. It's actually going to create more new and interesting jobs once there's convergence of at least in this space, neurotechnology and AI, and I'm assuming that will be the case in all of the other spaces as well. The only people who will be left behind are those who don't have an understanding of what AI can do for their workflow or their workspace.
Right.
So those are the people who will potentially be left behind. But even those with a preliminary understanding of where AI can help in their workflow from a clinical or administrative standpoint, and even in the BCI and neurotechnology space, there's going to be new and interesting jobs along the lines of what Harvey also alluded. So how do you train people to be in that space? So that's one of the goals of that implantable brain-computer interfaces community that I'm a part of. We have one work group that is looking at the educational aspects of this. This is a newly constituted work group in Feb 2025. So it's only been about 3 months, maybe less than 3 months. And so one of the work groups is looking at all of those educational competencies that you'll need going forward from purely the neurotechnology and BCI standpoint.
Srikanth, is this?
And we haven't even talked about AI integration with this at this point. So that's going to be coming down the road.
So is this, and I'm sorry, is this group including national like organizations or international or both?
It's currently national, but there's an international component to it, and it's the only clinical neuroscience group that the FDA is part of.
Oh, wonderful!
So we actually have FDA people sitting in and actually participating in the work group.
So can you, do you have a link or something that you can put in the chat for this group if somebody wants to learn more about it?
Sure.
Can you do that?
Sure.
And Kalpana, do you want to introduce yourself? You're new to the group. Dr. Reddy?
Yes. Hi. An excellent presentation and really interesting discussion as well. This is really not my sort of forte. I'm a molecular genetic pathologist, and heme path and oncology is my sort of area. I've also done clinical informatics. I guess this may be a little far out, but I was just wondering if anyone had some thoughts about DNA, which has been discussed as a potential medium for data storage, and things sort of along that sort of realm. I'm sorry, I'm just recovering from a viral infection, so it's a little, my throat is a little off. So, artificial neural networks and computation on data stored in DNA. Does anyone have any thoughts on, about that aspect?
Where are you from, Kalpana? Where do you work?
I'm currently working actually for neogenomics, but I'm from, I trained at University of Utah and at University of Chicago, and I worked in New York for a while for Genzyme and for Northwell, things like that. So
where are you now?
Currently, I'm attached to headquarters in Florida for NeoGenomics.
I see. Good.
So,
All right. So, anybody know anything about computational DNA?
Yes.
Go
So
for it.
there's a group, there's tons of, by the way, we're also in pathology and oncology, Kalpana. So I'll add you on LinkedIn, but Sandbox AQ folks, a division of Google, has got a lot of projects in this field. They're both using actual DNA to store. It's not feasible or effective use of storage at this point, but they are using it to store some codes and sequences. But furthermore, the better usage is they're actually simulating pathology and end-to-end drug discovery, all the way from like identifying a tumor in a patient with a specific, biomarker profile or genotype and phenotype, and then work all the way backwards and say, okay, here's the therapeutic and the companion diagnostics. And they're doing that all simulated in the cloud.
Oh, that's great. I haven't really delved into this, but this being with this group is sort of sparking some of this interest, and probably a look into things like that. Thank you.
Sure. So Sree, let's get back to some basics, because we don't have a lot of time left in terms of action items. So given all the multiple issues that we've talked about, some of which are generic, some of which are sort of unique to brain-computer interface technology, and given the political and economic environment that we are living in, particularly as it relates to funding, particularly as it relates to university funding and grants, given what we've heard from Paul about the investor appetite, pro or con, so if you as a scientist or a doctor in clinic are interested in pursuing this, what would you recommend?
Basically, just before all of this funding imbroglio happened, NIH, BARDA, and the Brain Initiative had put in about 2.8 billions into this domain. That's just before all of this recent changes happened. So the way to go forward, the way I look at it, is public-private partnerships are obviously very, very critical. And entities that are in this space are the ones that you need to reach out, given the problems with federal funding at this point. That's the only thing I could come across when I was looking up this topic. If no federal funding, then VCs and startups.
So, Paul, what's your response to that?
Yeah, I agree 100%. It's a nightmare. It's a bloodbath of getting grant funding right now in the next 3 years, I think. Every science professor has either already laid off or created a plan to lay off, is already getting prepared to tell the PhD students that you have to find your own money or pay for your own years 3 through 5.
Kathleen Meyers.
So it's a bloodbath out there. And then the only way to go is private money. And then even within private money, the larger VCs are all frozen now because of economic certainty. I just got off the call this morning with 2 friends that are in VC. They're just like, we're going to take vacations. They cannot do due diligence because of the uncertainty. They cannot complete deals because of uncertainty. So I think, and meanwhile, there's an increase in family offices and angels that want to put money into healthcare. So I've had like 20 meetings in the last 2 weeks with family offices and angel investors who want to put in money into projects.
So the other thing I wanted to add is there are 3 companies that are showing a lot of interest in this space. One is Google Brain, Meta Reality Labs, and IBM. So
and all of their venture groups, venture arms.
Correct. And so those are 3 entities that are significant interest and stake, for example, in this space.
Um, let's get back to the medical education piece. Anthony, we've obviously on these calls had a lot of conversation about who teaches what to whom and how. But these days, it's really more about what exists now because there's so much stuff out there, large language models and predictive analytics and all that stuff. So there's a lot of stuff to learn about what's going on now. But what, if anything, in our perspective, do we need to change to? I mean, we're looking who knows how long any of this is going to be a reality. So what's the lens through which we should view this? Is this a neurosurgical competency, a resident competency that you're going to have to learn this stuff because we think it's going to happen 5 years from now? Or let's just worry about what's already here now, and when that happens, we'll deal with it then? Or who's going to teach people this stuff? Why don't you give us your 2 cents on that?
It's like about 5 big topics all rolled into one. But I like that Sree mentioned the word imbroglio because that's what it reminds me of right now. In terms of education, from college to, we talked about college and medical school, to clinical training. I think what I'm seeing across the different, not just in the US, but around the world, is the students are actually empowering themselves much more than we think right now on using at least the generative AI tools to learn. And I think the deans and the professors will have in the next couple of years a major catch up now, because they don't realize how the students are actually very active. At least a cohort of students are very active in using these tools already for both learning and studying. So I do think that the deans will wake up in the next few years to accommodate the tremendous change in the technology. Remember, technology is on an exponential curve, as I always say, but medical education is on a trajectory that's linear, and the gap is getting bigger and bigger. Seems like the gap is getting bigger each month in terms of what they need to study. But the major paradigm shift has to come from how we want to have our students learn. And right now they're studying and memorizing instead of doing critical thinking, which I hope a few schools will be willing to say, we're going to have our students do better in the critical thinking.
But Anthony, doesn't that change when you have an AI in your pocket, or just listening to you or in your eyes, like you're seeing?
Of course it does. Yeah, of course it does. But that we have to educate the deans that the world has changed in terms of what's expected of a clinician. I'd much rather a clinician have critical thinking taking care of me rather than be a good have good recall of memorized facts. And that doesn't help the patient per se, other than just having a few shortcuts here and there. But ultimately, we want our clinicians to be critical thinkers, which is what's really missing in education right now.
Other questions?
I just want to mention that I do daily education on my medical students, residents, physician assistants, and PAs. They come in and rotate, and I teach. But the most important thing I do is I teach them about how they had to learn it and understand it and be up on it. So this is our future as physicians, as clinicians, to the public that we're treating. And I also plan on giving a lecture at Hofstra University School of Medicine on AI. Now, of course, I know much less than all of you here, but I'm coming to all the meetings to educate, to understand better, so I can give the right information. I think that's what we all have to do. If I know Dr. Chang does this all the time, I'm learning from him on how to do this. And I do this in the office every day. And they walk away with so much information that they had no idea that's out there.
Thank you. Other questions or comments?
That's a great
So the only
comment.
thing I wanted to add, I'm sorry, Dr. Reddy, go
Oh,
ahead.
no, I was just going to say a while ago, maybe almost 4 years ago, I was aware of Dr. Chang's ABAIM, and I was advocating that to my son and to some of my residents and fellows. So that's a great point that Susan had made about trying to spread the word and to get the younger people.
You're making him blush.
Kalpana, it sounds like you had a fair amount of experience in industry, no?
No, not really. Mine was really on the diagnostic side. So I benefited from the pharma in the sense, we were sort of protected to do our diagnostic and a little bit of research, but not really, in the direct the industry. But anyway, I didn't mean to interrupt Dr. Shree. Please go ahead. I just wanted to mention about the AI education part. Thanks.
Sure.
So
the only thing I wanted to add was there's a lot of issues around the neural data privacy going on at this point. And an entity called Pegasus Strategies puts out an annual report in this space every year about the current state of the art in terms of neurotech. And their last 2024 report basically said, when companies have access to your neural data coming from all of these wearables, sensors, and brain-computer interfaces, for example, only about 25% of them actually take care of your data following all of the current gold standards in terms of privacy, ethical considerations, and data protection. So that's a very scary number, because it's only 25%. It means that 75% of the data is available for people to misuse. So 2 states, Colorado and California, have put in place some new laws in terms of neural data privacy. And I suggest for those who are interested in that space and neuroethics to look for those. I don't know if I have them on the deck, but if you reach out, I'll be happy to send you those references as well.
Colorado is so far ahead of the curve.
And definition of patient identifiers and privacy are changing because of AI as well. Because right now, if I were to get a 12-lead electrocardiogram on all of you, I should be able to tell which EKG belongs to whom. And I bet it's even easier with EEG, Sree, because that's even more individualistic. So all of the data that we think are not necessarily private are actually we have to change the definition.
Yeah.
Well, this has been a great conversation.
Wait, can I say something?
Yeah, sure. One last
Speaking of
comment,
education, speaking of education, I highly recommend this book.
What is it? What is it? Anthony's book?
Oh,
no. Yeah. Okay.
Okay, here we go.
Everybody here knows Anthony's books, right?
Yeah. No, but yours is not signed. Mine is signed.
All right. Well, thanks very much.
On the second edition.
Yeah.
I'm working
thanks
hard
very
on the
much
second edition because things are changing that fast.
Yeah.
So hopefully that'll be out this year.
Thanks very much for joining us. Great comments and conversation. Susan and Hansa, we're going to have to tee you up for the education session. Thanks for offering to do that. Thanks for
plan.
Yeah. Thanks for joining us, and we'll see you next month.
Goodbye,
Bye.
everybody.
Thanks, everybody. Appreciate it.
Thank you.
Thank you so much.